All right, folks can let me know if they can see and hear me okay. Need to pull up I have the live chat open, so let me get that up and going. We have Mike Poland on here today. Let's see. It's not showing me. Usually it shows me the live chat. Hang tight here, Mike. Sorry.
Sure, no problem.
Okay. Um, okay, well, I can't see the live chat, but apparently we are on. Folks can see and hear us, so that's good enough for me. We'll figure that out. So great. Well, thank you everyone for this special year-end live stream broadcast. I'm Geology Professor Shawn Willsey. We're joined today with USGS scientist, chief scientist of the Yellowstone Volcano Observatory, and frequent guest, Mike Poland. Thanks for joining us, Mike.
Yeah, my pleasure. Thanks for having me on.
Awesome. Yeah, so basically what we want to do here is just maybe go through a little bit of Q&A. I have a couple questions for you, and then I can have Amanda Jo send me some of the questions that she's got through the live chat and such. So let's just start with basically, one thing that's kind of popped up lately on my radar, and something I know you can speak to better than I can, is this seeming connection that some people seem to have with the frequency and the triggering mechanisms of earthquakes and some of the things that happen out in space with these different types of cosmic particles moving through space. If you want to speak to that, that would be a great way to start.
Yeah, I mean, I see this all the time too, right? That, there's a class, whatever, solar flare that's, aimed towards Earth. And so we can expect earthquakes and volcanic eruptions and so forth. And regardless of whether or not a noteworthy earthquake or eruption happens, that myth never really sort of goes away. And I think the problem with this, I mean, there's some problems with mechanisms, right? Like how does one cause the other?
Right.
But even ignoring that, what bothers me about these is that it's so intensely cherry picked. So for example, someone will say, there was a solar flare, and then 2 days later, Kilauea had a lava fountain. Is that coincidence? Yes, it is. Because Kilauea has had 38 lava fountains this year, right? There was a magnitude 6.9 earthquake in wherever, within 2 days of the solar flare. Is that coincidence? As a matter of fact, yes. There are an average of like 130 magnitude 6+ earthquakes on Earth every year, right? So that's like one every 3 days. So I guess it's easy to draw that line and you say, there was a solar flare and there was an earthquake. Or there was a, pick your phenomena, comet by, or there's a great song on the radio or something like that. But you got to look at it from the other way. How often do these things happen anyway? So is there really a tight connection, or is it just coincidence? Because, coincidence is a thing. Most people, before they die, they blink.
Really?
But who's going to say that blinking is the cause of death, right? Because we blink a zillion times a day. So I think that's what I would encourage people to look at. There's a lot of fantastic stuff out there, especially on YouTube, about, these correlations between different things. But you got to think about how often stuff happens anyway. And a lot of times our perceptions are skewed because the media may not report that many volcanic eruptions. And then, something like Kilauea has a spectacular eruption, and they'll report on volcanoes a bit more often, and it seems like every volcano on the planet is suddenly erupting when it's normal. So
do you think it's like just some, I don't know, human desire to like link things up, and like it helps us make sense of like our universe? It's obviously very appealing, and a lot of people kind of are attracted to that kind of a line of thinking.
Yeah, I mean, I think humans like patterns, right? I mean, we seek patterns out in a lot of things. I do the same thing when I'm sitting at a stoplight. I'm looking at all the blinking turn signals and looking at how they match up and stuff, just because I like patterns like anyone else. But it's and that's an important thing, because patterns do exist, right? I mean, but in order to identify those patterns, we have to look at things as a very systematic and comprehensive way. And I think there's a desire to find some easy things like, oh, well, there's a whatever happened and then something else happened. Are they connected?
Right.
You know, there was a volcano that erupted in, I don't know, volcano erupted in Southeast Asia, and there was an earthquake in Italy on the same day. Is that connected? I saw someone claim that Kilauea seems to erupt when there's a full moon, within a couple of days of a full moon. Kilauea it's erupted 38 times in these lava fountains in the past year.
Yeah.
Right. Chances are there's going to be a lot of them that are within a couple of days of a full moon.
Right.
Also a quarter moon, also a three-quarter moon, also a new moon, also a half. Right. So you really have to be careful when you're seeing these patterns to try to look at it from every direction and understand whether that pattern is real or whether it's just sort of a perception bias, because it's pretty easy to get into the perception bias thing.
Yeah, we're just people just looking for different connections. But related to like the space weather and these particles coming from the sun and through space, I mean, to me it just never made sense, because earthquakes typically take place kilometers below the surface. Right. We know tectonic stresses and the movement of magma and fluids, those are some of the primary causes of why we get earthquakes. But it didn't even make sense to me how you could like get particles from space passing through kilometers of rock, and how would it have like the physical force to actually trigger an earthquake? I don't know. Can you speak to that a little bit? Or
yeah, I mean, there is a mechanism problem, right? Like the processes that generate earthquakes, that generate volcanic eruptions, how would those be impacted by cosmic radiation?
Yeah,
there's no link there. Now, I don't want to sort of dismiss things completely out of hand, because obviously there's a lot of stuff that we don't know, and things that we might have thought weren't linked or had any association maybe 100 years ago. Later on, we learned, okay, there is some connection, I don't know, between radiation and cancer or something like that. But we have not been able to find not only any mechanism for those sorts of connections between sort of like a solar flare and what's happening to the tectonic plates, but we never found the pattern in the first place. Right. And so there's no, people will occasionally say, well, you've not disproven this, or you've not disproven this connection. But it's like the connection between blinking and death.
Yeah.
Like you're asking me to disprove something where there's no connection anyway.
Yeah.
Right. And so that's part of the sort of logical problem that gets created, that well, you can't disprove that this isn't related, but there's no relation to prove or disprove. There isn't any. There's no there.
Yeah, there's no connection, so, right?
Yeah.
And I mean, that's just the difference between science and the supernatural realm, or just anything else. Is like we have like ways of like testing things and making a hypothesis, and it should be something that is repeatable, that a pattern in nature that we can observe and test, and then see that it's scalable, it repeats in nature, and a lot of these things just don't kind of bear that kind of scrutiny.
And I think you see this with some of like the kind of earthquake prediction folks, right, that they will make some prediction or forecast or something like that, and it doesn't bear out, and they'll do it again and again, and then at some point it'll be, all right, well, I forecast that there was going to be a magnitude 6 somewhere in the Pacific Rim within a week, and there was. Yeah. And suddenly that's well, I know what I'm doing. Well, you've ignored all the times you were wrong, and you haven't explained why you were wrong. Right. And you've also just managed to catch one in an area that it often happens anyway. Like a magnitude 6 in the Pacific. Yeah, like a magnitude 6 in the Pacific once a week is not outlandish, right? So but of course, a lot of those don't get reported because they're happening in some random area or in places no one feels it, and so those sorts of that's why I say you've got to look at all of the data. Volcanic eruptions and solar flares. There are worldwide catalogs of eruptions. There are catalogs of space weather over time. Look at those and see if you can actually find a connection. And when you do that, there just isn't a connection between these things. Yeah. That's not a popular opinion with many people. Right. Many people on YouTube, especially, but you sort of can't deny the data that we have.
Yeah. No, I think it's a good way to summarize that. Yeah, thanks for some clarity there. Kind of switching gears, how about a couple other little questions I had, and then we can
Sure.
get to some viewer questions. So I'm sure you saw the last eruption at Kilauea, episode 38, which was very dramatic, pretty spectacular. Took out one of the very popular live cams that they had there. And I didn't really see from the USGS in their updates. They just mentioned that the south vent, quote unquote, exploded. And you could see that. Anything you've heard of or know about that in terms of like what caused that? Was it just an increase in either lava supply or gas? Obviously, it was a pressure change of some sort, but maybe add some insights there.
So oftentimes what happens with these lava fountain eruptions, especially one that's lasted as long as this sequence has, you build up these gigantic piles of material around the eruptive vent, right? And you can see that. Sorry, I'm having to.
You got a visitor.
Yeah.
No problem.
We have a power outage at CDO today, so I'm at home, and I have an office mate.
Right.
So oftentimes with these great big piles of tephra, right, that accumulate and spatter and so forth, it's not structurally sound. And especially when you start a lava fountain in something like that, it'll start to slump into the vent, and it can actually clog the conduits. Now you're trying to force out a whole bunch of lava that's under pressure, and then you just plug the conduit. That's going to result in some buildup that will eventually blow out. And so that's probably what happened there. And that may ultimately be what turns this fountaining series off, is that at some point the conduits are just going to get completely plugged up with all of the debris that they put out. Because these cones, they sort of, in addition to, you can see it in the time-lapse footage, that they sort of fail slowly over time outward. They also fail inward. Stuff's going to fall into that conduit and begin to plug it up. That's also probably why the fountain sort of rolled over and took out the V3 camera, was because stuff sort of gets into the vent and it blocks it, and it may cause the fountain to sort of like putting your finger over the edge of a hose.
Yeah.
That sort of thing is common with lava fountaining eruptions.
Yeah, and it was pretty dramatic. I mean, it was vertical-ish for the first couple hours or however long, and then within just a few seconds, it switched to like maybe a 50, 60 degree angle. It was very dramatic.
Yeah, so these conduit systems are pretty easy to disrupt when you've got access to that much junk, laying around the vents. And those vents have built up really, really high. I mean, they're sort of getting up to the height of the caldera rim. It's got a little ways to go yet, but there's a lot of material there that's unstable. And especially when you start, spraying pressurized molten rock through there, it's pretty easy to see how it could fail inward, and then you're going to sort of build up pressure on the other side of that plug.
Right, and then it's changing the sort of trajectory of that ejected material, because if it's plugged up on one side, it's going to go the other way. Yeah, interesting. Okay, I just didn't see. They just said it exploded, and I'm like, well, I knew that, but and then they just didn't have a good explanation like they normally do, and so I was just wondering if there was some consensus on that, or what your opinion was.
That's often the cause. There can be other, reasons that maybe there's an accumulation of volatiles and it sort of, really busts out. But usually there's something kind of like a little plug that then gets blown out in sort of a sudden event.
Okay, interesting. Another question is on INSAR. So whenever we get an INSAR image, like an interferogram, we get all the colors and that sort of thing. But we also get the little arrow at the top, which is very instructive, that shows us which direction the satellite passed over that region. And then there's usually a little small arrow that indicates which way it was kind of looking.
Yeah.
And so my question is how, and maybe I think you've explained this before, but just maybe one more time, how does that flight path affect the actual image we get, or the interferogram? Because like with Iceland, we sometimes see the little bullseye bulge is in one interferogram, and then you look at another one and it shifts a little bit. Some people think like, oh, the magma's moving, and it's really I think this flight direction thing.
Yeah, so one important aspect of radar satellites is that they're not looking straight down. They're looking off to the side. And so you can imagine an example would be like, let's say you're flying over a city, right? And you look out the window, kind of at an angle, at a tall building. The top of that building would appear to be, like if you were to sort of map that onto a flat thing, would appear to be like, a couple of streets over, right? Now imagine you're flying on the other side of the building and you're looking at that on an angle at the same building. That same building, the top, if you mapped it on a 2D plane, would appear to be several blocks the other direction.
Right.
That parallax is what it's called, right? That sort of viewing perspective issue with something that's got some elevation to it or some relief to it. And so because we're not looking straight down, you're looking at an angle, either from the east or from the west, that will smear things out. And so depending on the pass, you might see a bullseye that's smeared in one direction, and then the exact same thing viewed from the other angle will be smeared in the opposite direction. So that's one of the challenges with interpreting interferograms, is that what you're seeing is not exactly mapped onto the point on the ground. There's a parallax issue,
right? Because
you're looking at it from an angle.
So it's giving you the elevation change data in terms of the relief change in that area for each pass, but the location is a little bit off depending on that angle and that kind of oblique view.
Right. Yeah. So what you're looking at in that interferogram is not vertical motion. It is all the motion that's happening in the line of sight of the satellite. Okay. And so since we're looking at some angle, you're seeing a mix of horizontal and vertical motion. Right. And when you map that out into a two-dimensional structure, it has this smeared out look. Things that are perfectly in the direction of the satellite would appear to be a perfect bullseye. Yeah. But that never happens because there's never the right combination of things. But it can be deceptive because there are times when you'll look from one direction and think, I know exactly what's going on. That's magma accumulation in a spot just like this. And then you look at it from the other direction and it looks completely different, not even smeared in a different way, but very different. And from that, you might say, wait a minute, this is a dike intrusion, not just an accumulation in a sphere or something. It's a dike intrusion that has a certain trend. Another problem with this is that we are somewhat blind to some deformation because you're looking at this angle that's mostly up, down, and east, west. So north, south, horizontal motion, we're not very sensitive to. So there are some motions, like let's say you have a faulting event that moves land in a north-south direction. That's not going to show up very well in an interferogram. And an example is in 2018 at Kilauea, there was a magnitude 6.9 earthquake on the south flank, huge amount of motion on the south flank. One of the directions did not see that motion very well because it was sort of happening horizontally.
It's blind spot kind of, right?
Exactly. But then when we look from the other direction, we saw it.
Yeah, that was my question. If you had two satellite passes that were 90 degrees to each other, you would have a better sort of three-dimensional sense of what's moving and what's real.
Yeah, and that's part of the problem with satellites is that you sort of have to put them in these sort of regular orbits. They're typically polar orbits. And so most SAR satellites are not sensitive to north-south. Not that sensitive to north-south. There's some. But you can fly with a radar on an airplane. And you can do that in any orientation you want. And that's been done in several places where you put a radar on an airplane and then you go north-south, east-west.
Yeah, you get more details that way. So
exactly. Yeah, and then you can really see it from every angle.
Yeah, because they've got to fly the path. They make one pass and that's one set of data. They've got to make the exact same pass, however much time later. And so they never really look down. Is there any instance where it does look straight down, or is that pretty rare?
No, that's pretty rare. Okay. It's the physics of the radar signal to get the high resolution don't work when you're looking sort of straight down. It sort of needs to be off to an angle. Okay. Radar's a weird thing. Yeah. And even when you're just looking at a radar image, not even interferograms, there are shadows. There's weird things that like the parallax effect that make it look like the side of a mountain is sort of laid over a bunch of the surrounding topography. So radar is it's a difficult thing to interpret. It's pretty non-intuitive.
Interesting. Okay, well that clears it up a little bit for me. So let's see. I think I had one more question, but Amanda Jo, if you want to send me any of the viewer questions that we have so far, I just want to email those to me. That would be great. Well, Amanda Jo wanted me to ask you a non-technical question, like when are you coming to Iceland to explore? Have you been to Iceland ever, or?
Yeah, I've gotten to go to Iceland 3 times. Twice it was as part of a class on, once was on plume ridge interactions. Iceland's an interesting place, right? Because you got the mid-Atlantic ridge coinciding with a mantle plume.
Right.
And so there was sort of a class for, at the time I was a student on plume ridge interactions. And then I went a few years later for a class on magma tectonic interactions. So how volcanoes and faults basically interact.
Right.
When I was sort of early in my USGS career. And those were amazing courses because you take these field trips to places like Reykjanes and you look at structures and really get a feel for how magma moves around in the subsurface and interacts with different structures. And then there was a really great scientific meeting there in 2008. One of the IAVSE meetings. It's the International Association of Volcanology and Chemistry of the Earth's Interior. Every 4 years, they do a kind of a world meeting of volcanologists, and that in '08 it was in Iceland. So that's the last time I've been there. I got a lot of colleagues that I really respect in Iceland, and I really would like to go visit them again.
Sounds like you're due. So,
yeah, why not?
When's the next IVECI or whatever that acronym was?
IAVSE.
Yeah.
Let's see. They just held one this past year in Geneva. So I think the next one is going to be in Costa Rica in 2029.
Oh, okay.
Not too many people from the USGS go, just because it can often be expensive.
Right.
It's difficult to fund it. But there's we had a meeting in Portland, Oregon, that meeting in 2017. And that was fantastic because it was right across the river from CVO.
Oh, yeah,
large
perfect.
Staff could go. And yeah, that was a fantastic experience.
Yeah. Oh, perfect. Well, maybe there's a chance. There you go, Amanda Joe. Okay, a couple questions from some viewers.
Sure.
From John Falders, what was it like for geologists to observe a volcano from birth to extinction? I'm not sure if he's referencing a specific one, or an extinction's a dangerous word in the volcano world.
Yeah, that Haile Gubi sort of highlights that. I think from birth, you could take something like Paracutine, right, which popped up in the Mexican cornfield in the 40s. There was also some that they were volcanoes that were below sea level, but then broke sea level, and you could sort of watch it form. I think that's especially in the case of something like Paracutine, it's a pretty rare opportunity to watch structures form. Or something like Kilauea, you're seeing a new vent, right? And that's not a volcano, but you can see these vents form. And you get a lot of insights into the physics of the materials and how eruptions build the structures that we see. So, for example, drive around northern Arizona, right, around the Flagstaff area. There are cinder cones everywhere: Sunset Crater, SP Crater, Strawberry Crater, Merriam, Sproul. Looking at Paracutine, we saw how those things formed because we could observe the actual eruption. Now, then, of course, you find there's exceptions or different ways behaviors happened, but observing those eruptions is really the key to understanding what may have happened in the past. I think volcanology is fundamentally an observational science. And the more we look at eruptions, the more we understand how certain things we've seen in field that we didn't observe form came to be. And this is sort of fundamental. There was initially, and I'm talking hundreds of years ago, there were thoughts that some igneous rocks precipitated out of ocean water.
Yeah.
This is how igneous rocks came to be.
Right.
For example, the columns, like you had Giant's Causeway in Ireland, the columnar basalt. It's like, oh, that must have come out of water. And it wasn't until people actually saw eruptions and saw those structures eventually form that it became clear that, no, that's not quite how things work.
Right.
Sorry. Office mate was trying to steal the camera again.
Yeah.
So just the observational side of things is key for understanding, interpreting things that we see in the field.
Yeah, I mean, we look at the landscape today, and it's a bit like a crime scene, and we're like, here it is. But then we, on occasion, like with Paracutine and some of these eruptive events, get to see the crime take place. It's almost like catching a crime with a camera or something. Like we saw the whole thing happen, and then we can put those together, which is really powerful instead of
that's a great. I love that analogy because I think a lot of geology in general is like being a detective, because you're trying to use evidence that of something that happened that you didn't see to reconstruct what happened.
Right.
So I think geologists are basically incredibly long-term detectives.
Yeah. Go us. Yeah. Yeah. Okay, so question from Sandrine in France. This is about with one of your recent YVO updates. Your let's see, your September YVO update short video. She said that you said, quote, the Yellowstone magma chamber is mostly solid. We know this from seismic imaging, unquote. So she wants to know if you can explain what seismic imaging is and what tools scientists use. And she says, thank you.
Oh, well, we'll see if you really want to thank me after this explanation. Right. This is any good. So seismic imaging, I often say this is like taking an MRI of the Earth.
Right.
And the way it fundamentally works is that you have an earthquake over here and you've got a seismic detector over there, and the earthquake waves pass from the source up to your receiver. And if you have enough receivers spread throughout an area, you can tell something about how fast the seismic waves are moving through the subsurface and where they're slowing down, if they're slowing down. So if there's an area that's hot, then the seismic waves will slow down. If there's an area that's molten, there are certain seismic waves that won't even make it through the molten thing. So if there's sort of like a reservoir of molten rock and there's an earthquake over here and a receiver over there, you will only see certain types of seismic waves because some of them are stopped by the molten material.
Is that real quick question? Sorry to interrupt. Is that because of the temperature of the materials, or is it more the density of the materials, which is dictated by the temperature?
Yeah, a little of both.
Okay.
It's like, so the real thing is, the P waves and S waves, right? Pressure, compression waves, and shear waves. Shear can't happen in a liquid. Not really, anyway. So if you have a lot of liquid between your source and your receiver, those shear waves won't pass through it. And so you'll see the pressure waves, which can go through liquid. You won't see the shear waves.
Right.
And it grades, right? Because no magma chamber is 100% molten or 0% molten. So there are gradations in that. And it's by looking at those subtleties in speed and the type of waves that you get that you can tell something about the temperature of the material beneath the surface. And you can sort of localize, if you have enough instruments, localize where these things are. And so that's the key, is having enough receivers, enough sensors to be able to map that out. Because the more sensors you have, it's a bit like, a camera resolution. If you've got a 1 megapixel camera, for those of us that remember the dawn of the digital age,
right?
Yeah, like, hey, well, I've got a 1 megapixel camera, and you just, you can tell, like, all right, well, there's a mountain. Now we've got, whatever 25 megapixel cameras in our pockets, and you can not only see the mountain, you can see the trees on the mountain.
Right.
And so it's the same thing. Like, the more receivers you have, the better your resolution is for what's happening in the subsurface. So you need to do these experiments with a lot of sensors out. And that's what's been going on at a lot of volcanoes recently, is scientists putting out these arrays of hundreds of seismometers. And that sort of increases your resolution to see what the subsurface looks like.
Does it give you a pretty good estimate of how much of that magma body is solid versus liquid? Like, after you do your seismic imaging, you can, not definitively, but approximately say it's 60% crystals, 40% magma. Is that kind of one of the end products of that? Yeah.
And that's part of that is based on modeling. So, we don't have a one-to-one correspondence of, all right, well, the seismic wave went this speed, therefore it must be X,
right,
percentage. But you look at sort of what does a magma chamber look like? Well, it's probably crystals, because crystals form in magma as it cools, separated by little bits of melt. And depending on how you model the shape, the lattice, the pattern of crystals that melt, you can get different seismic velocities.
Right.
And so there are certain ones that sort of make sense based on, geologic relations. And when you plug all those things in, you can come up with usually a range of the likely percentage melt. Another thing we can tell from these seismic imaging studies is maybe the layout. So, for example, at Yellowstone, we have a nice idea that if the melt that is there seems to be stored in these little horizontal lenses that we call sills, as geologists. There's horizontal, lenses of melt separated by more solid. And the reason we know that those horizontal things are there is because if we look at seismic waves that pass vertically, they are moving faster because they're only having to punch through these little thin lenses.
They're going mostly
seismic
through
waves
rock,
that move horizontally. They're going along the lenses. And so they're sort of traveling along these warmer things, and it takes them longer to get where they're going. So by looking at even just sort of the vertical versus the horizontal seismic wave speeds, you can get an idea of how the structure of these things.
And really a 3D model of like what that magma, I mean, that's like, as we dealt with this stuff in Iceland the last 2 years, like, you know, I envisioned like initially, you know, the magma's coming up, it's building a sill, but then with each eruption and each pulse of magma, the longer the magma stays in that sill, it's partially melting the rock, it's building more space for itself. And that's ultimately why we're seeing the GPS receivers track upwards with each successive eruption, is it's building more space for magma to be stored. But it's so hard to, you know, I drew some very lousy cross sections at the time, but what that actually looks like, I mean, that's like one of the key things we'd like to understand is like, what is the actual 3D geometry of these things?
Yeah. And there's something even more spectacular, in my opinion, in terms of the monitoring. And that's, let's say you're starting to inflate a magma chamber, you're pressurizing it. When you do that, you're going to cause cracking in the surrounding rock, right? Because you're building up that pressure. We can see it in lots of small earthquakes. Well, that cracking creates damage, maybe some open spaces that weren't there before. When you've got that open space there, seismic waves will slow down a little because you're not passing through as coherent a rock.
Right.
And so there are techniques that exist, they've been around for a decade or so now, that can look at sort of the continuous seismic wave speeds. And just say, you know, these are the kinds of things where you can use a single or a few sensors and say, things seem to be slowing down over time. And that correlates with pressurization of the magma chamber. And so we think that there's, you know, like an increase in pressure because there's more damage being recorded by the rock because things are slowing down.
Right.
And the source in this area is not necessarily an earthquake. It's the background seismic hum of the whole planet. And so, you know, you've got this sort of baseline seismic noise that you can record at a sensor. And as it changes, we know the background hum isn't changing. So what's changing is local conditions to that sensor. And if you have a bunch of sensors, you could say, there's sensors that are right on the volcano where things seem to be slowing down, which implies there's more damage, more cracks forming because we're seeing a pressurization. So we might even be able to use this sort of seismic wave speed as a monitoring tool.
Yeah, because I imagine with each eruption, it doesn't go back to the same, like the conditions have changed, the baseline conditions, the volume of the system, the cracks and everything, like you said, like you're starting in a new place. And so it's hard to like, you know, model that moving forward to some degree.
Yeah, I mean, and it's super messy down there, right? I mean, it's not a bunch of solid rock with a giant cauldron of completely molten material down there. It's a mess. And so a lot of these techniques, the ones that are designed to see change, I think are particularly effective because it doesn't rely on the picture being correct. It just relies on looking for changes in whatever's going on down there.
Yeah, oh, that's fascinating. Wow. Okay, a couple more because I want to make sure we have time for all the questions here. So this is from a 12-year-old, Shannon Lujan. I am 12 years old and I have another question. Can you tell if Mauna Loa is due for an eruption?
We can, and that's based on all of the monitoring data we collect. So, you know, we would see inflation of Mauna Loa before it erupts. We'd see changes in earthquake patterns and so forth. And that is what allowed a decently accurate forecast of the 2022 eruption to happen, because we saw some very interesting changes in where magma was accumulating and the stresses that were being generated by earthquakes. We are not seeing that now. So based on our understanding of Mauna Loa and the patterns that we expect to see prior to eruptions, Mauna Loa is not, you know, going to have an imminent eruption. It will erupt again at some point. It's one of the more active volcanoes on the planet, even though it hasn't had that many eruptions in the last, you know, half century or so. But we expect to be able to see those increases in pressure and changes in seismicity that are a sign of magma ascending to higher levels. And
so the 2022 eruption was just a case of a batch of magma in the deeper system rose to the surface, much of that or some portion of that erupted, depressurized the system, and now we're just kind of waiting to see when the next pulse comes up.
We're in recovery, basically, in recovery mode.
Right.
Yeah, and one of the interesting things about that 2022 eruption is that some of the geologists looked at crystals that were in the lava that erupted. And by looking at the crystallization history, you can basically look at the rims on the crystals. They're almost like tree rings. They could see evidence, and they knew the timing that the crystal formed over, that there was an influx of magma a few months before the crystal erupted. And it ties very well to when we saw changes in inflation, changes in seismicity. So this allows us to link what was actually happening in the magma chamber based on the crystal forming to what we were measuring at the surface. And that kind of information is just invaluable for future
two lines
monitoring.
of evidence that converged with, the same kind of trend there. Very cool.
So we're in a much better position now for being able to interpret the measurements that we're making at the surface, like deformation, seismicity, so forth.
Yeah. So stay tuned on Mauna Loa. We're not done there, right?
No, it's going to erupt again, but no sign of it being an imminent sort of thing.
Right. Okay. Let's see. I think this is going back to Kilauea's episode 38. This question here, their handle is I Love Etna, great volcano thing. It says, how much pressure was there when the south vent changed direction? Is it possible to measure that?
That's really difficult. I've seen that question a lot. Like, hey, how many PSI was the pressure to drive magma? It's not something that's particularly easy to measure. And I don't have an answer for you, I'm sorry to say. Part of the issue is because there is gas dissolved in the magma. That's what's driving eruptions, right? That's what drives magma.
That's where the pressure is, right? Is the gas.
Exactly. Yeah. So you could imagine, a soda, same thing, right? Like, what's the pressure in a soda before and after you shake it? It's going to change depending on how much gas, whether the soda is flat or whether it's fresh, how much of the carbonation exalts. So I'm sure we could do a calculation on that, and it might just be the simple physics of how high it went and how wide it was, how much the volume was.
Right.
But to me, it wouldn't mean that much because it's really controlled by the gas coming out of the magma, and that's what's driving those fountains. That's what's driving all the activity. Well, so the soda analogy, I think, works.
Yeah, I mean, the gas pressure that's in the magma, the way I understand it, it kind of is what it is. There's a finite amount of that there. And then as you get it closer to the surface, that gas is expanding, so it's occupying more volume. And then you add to that the size of the vent and the conduit it's passing through, and that's really going to dictate what looks like a highly pressurized, like, whoa, that shot up 1,000 feet into the air. Well, it might be the same pressure, gas in terms of gas volume, as something that's just effusively just spilling out of a crater if it's coming out of a very large, wide vent. Is that pretty accurate?
Yeah, there's a lot of variables like that, like the size of the nozzle, right? I mean, the you can turn on the water in your faucet or your hose, your garden hose, and you can control just how directed that stream of water is going to be. That has nothing to do with the pressure that's being supplied to the hose. It's all right at the nozzle. And then add into that, like, okay, now let's say it's soda that you're spraying out of your garden hose that was fresh, and you just shook it up, and it might blow up your garden hose if you completely cover it with your thumb, right?
I made the analogy that with this last year at Kilauea and the behavior of these eruptions, it reminded me a lot of what I've seen with geysers. And you sometimes see like the water rise, and it's building and it's building, and sometimes it overflows the pool, and then eventually you get the big geyser eruption. Is that a pretty good analogy, or are there any differences there?
I mean, there are some differences, but it's not a bad analogy because the geysers in some ways are these nice repeated kind of quasi-volcanic events. There's driven by exsolution of water vapor, from these reservoirs of boiling water. There are some obvious physical differences, like the viscosity of the material and temperatures and things like that. And, the presence of solids, crystals, and so forth. So there are some big differences. However, the geysering is sort of a repeatedly run experiment. And so, many arguments have been made, like, if you want to, one reason for studying geysers is because they can give us some insights into volcanic eruptions, and they're pretty safe, and they happen all the time, at some places anyway. So going out and studying geysers can give you some first order insights into how volcanoes work.
Right. Interesting. Yeah. Well, wasn't too far off there with that then. Okay, maybe two more, and then we'll let you go.
Sure.
If that sounds good.
Yeah.
I've got more than two here. Let's see. How about, well, let's do this one. Steenbach 63. Why is it so difficult to predict a volcanic eruption?
So I guess I wouldn't say it's particularly difficult. I've seen a lot of claims and comment streams and stuff like, oh, no one can predict an eruption. We're actually gotten a lot better at this. There is a difference between prediction and forecasting, right? I mean, prediction would be the timing, the location, and the style of
very specific.
Activity. Yeah. So prediction, I would say in general, it's hard to predict anything. Like weather prediction is hard. Forecasting, we have a very good bead on that. And so I think in terms of forecasting, volcanologists in general will do pretty well. And it's all based on two things, I'd say. One is a better understanding of the physics and chemistry of volcanoes themselves. So we understand more about the physics of how these things work. And the other is monitoring data. Because without monitoring data, it's like trying to forecast the weather without temperature or pressure data or, So in places where we have a lot of monitoring data, the forecast can be pretty good. Mauna Loa is a good example. There was a real good sense about a month before it erupted that it was going to erupt. And so there was a real emphasis on public outreach and education in that month. And lo and behold, the volcano erupted and people had the information they needed pretty fresh, right? It wasn't years before that, there had been a bunch of public outreach. Places where there don't have big monitoring networks, it's much, much harder to make those forecasts because you don't have the data. So I think in terms of forecasting, if there's good data, it's not hard. And in many cases, it's very successful. The places I think you can get in, not in trouble, but the challenges are sometimes magma doesn't make it to the surface. Most magma stalls before it reaches the surface. So you can see a lot of unrest at a volcano and think all our signs indicate magma's rising. That challenge, I think, is it going to make it to the surface? Is that intrusion, is that magma accumulation going to result in an eruption, or is it going to stall out just beneath the surface? And there's tons of examples of intrusions that don't quite make it.
That seems to be more the norm than anything. I mean, a good example of maybe Kilauea and Hawaii, so dialed in terms of like we've got the sensors and the forecasting methods are so impressive. And then what happened in Ethiopia this last month, where at least from many thousand miles away, it looked like just these things just pop off. Like, whoa, it just erupted. We didn't know anything was going to happen until we saw like ash drifting across Europe or Asia or whatever. Is that pretty fair comparison?
Yeah, I think there was a sense that volcano was active. It was emitting gases. It had, some rumblings, but there wasn't a local monitoring network, and Ethiopia lacks a state-run volcano observatory like a lot of other countries have. And so a lot of the expertise and a lot of the satellite imagery analysis was coming from other countries that were supplying that to partners at the university in Ethiopia, where some of the volcano kind of interpretation happens. So, because that particular event was not forecast or predicted, I think that's not a fair judgment to say, well, volcanologists can't predict anything. That would be like, saying I'm going to take away all weather forecasting information and then challenge you to tell me when a hurricane's going to hit. Right?
Yeah, we just didn't have the data there. The infrastructure wasn't in place. It's difference in just socioeconomics and all sorts of these other factors that kind of play into these things.
I mean, there is, if you look over the long term, and of course there are spikes in this, but if you look over the long term, there has in general been a decrease in numbers of fatalities associated with eruptions. You can tie that to monitoring.
Better forecasting.
It's not perfect. There are some things that are inherently, at least at this point, impossible to forecast. And, lava dome collapses. So if you have an eruption that's already going, and then a lava dome, which is sort of on a steep slope, suddenly falls apart and generates a pyroclastic flow. This happened at Semeru in Indonesia a few years ago, and it killed a few dozen people. Collapsing of that lava flow is something that's sort of like a landslide. And we don't have the ability to forecast or predict those sorts of events. But the volcano was already erupting. An example of a great big success story would be something like what happened at St. Vincent a few years ago, when there was a lava dome that started to erupt. And then over a 24-hour period or so, suddenly the characteristics of that eruption changed markedly. The seismicity changed, the effusion rate changed, and because it was being very well monitored, the local monitoring agency there in the Caribbean, run out of the University of the West Indies, put out a warning and evacuated people, got people out of there within 24 hours during the pandemic. And the ensuing explosive eruption that occurred caused no fatalities because people got out of there because the eruption was forecast based on monitoring data.
Yeah.
That's why you got to have the data in order to be able to make those forecasts.
Yeah, I mean, we definitely can save lives. We can definitely make better forecasts, but you put the resources in place. You got to have the network there, and that's problematic in some places for sure.
And I will say it's an advantage we have in volcanology. Volcanoes do give warnings, right? I mean, aside from these weird like lava dome collapses and things that are hard, like before eruptions, they give warnings. But you got to be watching for them. You got to be listening to them. Mm-hmm. But that is an advantage we have over other natural hazards. That volcanoes can give warnings sometimes pretty far into the future and allow us enough lead time to educate people about hazards, get them out of the way if it looks like an eruption's imminent.
Right. Yeah. Excellent. Wow. Well, we've probably taken enough of your time this morning. But
want to do one more? I can do one more.
One more good one. That was a good
one more. And actually, if you have the comments on in your video and people want to put comments or questions there too, I can come in later and try to answer some.
Yeah, so if we don't get to your question, viewers, put it in the comments to the live stream later, and then Mike will circle back in a day or two and try to address those. Awesome. That would be great. Okay, let's see here. Oh, this is a good one to end on, I suppose, from DJI Mini 2. Will the USGS replace the cam ruined by the tilted vent aftermath? Like, what are your, you've worked there, like, what's the sort of the standard operating procedure? What's your best guess on that?
Difficult to say, because, obviously you don't want to put it in the exact same place, although maybe you do. It survived
what are the chances
a whole bunch of episodes
again, right?
So my guess is that at some point there would be a new system that would go out there, but, those installations aren't trivial. I mean, it sounds easy, right? Let's go put up a webcam.
Right.
But they cost some fair chunk of change because it's not just the camera, but there's the cellular modem, the solar panels, the batteries, all the infrastructure. You've got to get all the stuff out to a site that's going to provide the view you want. So it's, and there's HVO doesn't have that many technical staff right now. So, there's also trying to basically dig out stations that get buried by tephra every time there's one of these fountains. So HVO is really oversubscribed with work right now. So I imagine it's not the highest priority in the world, but obviously having those camera views is cool, not just for
public,
YouTube Live.
Science,
there's cool science that can be done with these cameras, and so I would expect that at some point they'll probably try to get another camera maybe on that side of the caldera, but I don't think there's a timeline for it because it's going to be down the priority list a little ways.
Yeah, I mean, it really did, I think, give routinely some of the better views of all these eruptions.
Yeah, it did.
The V1 or whichever one's backed by Volcano House is kind of a ways away, but nice big picture view. And then the other ones, I think, on the north rim of the caldera, kind of looking down more. And depending on what the winds are doing, any one can be better than another. But that was definitely it will be missed, sorely missed. And hopefully
that was my go-to.
But it was pretty cool to see. If anyone wants to know what death by tephra looks like, that was a pretty good first person view of what that looks like. So
that was pretty dramatic.
It was for sure. So, well, thanks so much, Mike Poland again from the USGS, chief scientist of the Yellowstone Volcano Observatory, and frequent visitor. I think I didn't count, but this might have been your 5th appearance on the channel. So, I got to send you a gold star or something, a T-shirt. Just let me know. But we appreciate it, and you're always willing. I've never had you turn me down. So thanks for being a frequent guest here, and we'll maybe touch base again in a few months in 2026.
Drop me a line. Always happy to come on.
Okay.
I really enjoy chatting volcanoes, and I love the questions that people ask. So thanks. Thanks for that.
Yeah, we all love learning together. So, well, Mike, you have a great Christmas and holiday season with your family and your cat there. Hopefully the power comes on at the office. And
that'd be nice.
All right. Well, we'll see you soon. Thanks so much, Mike.
Thanks. Take care, everybody. Happy holidays.
Bye.
Bye-bye.
All right. So, let me switch over here. and get some other stuff up for us here. Great. Well, Mike's always awesome to have on these things, and we appreciate his time. Give me a second to get my webcam up. There we go. Guess I don't need these now. Yeah, hopefully folks can hear me okay. The one thing, the only issue I'm having here on my end is for some reason it's not showing me the live chat at all, which is a little disconcerting. And let me try one more thing here before we move on. I'm not sure I can see where, let's see. Video. Yeah, I'm not seeing anything obvious here for getting the live chat up. So I'll just rely on Amanda Joe. I got her over here on Messenger. Make sure everything is good to go now. Make sure you guys can see and hear me okay. And what we'll do here, team, as we kind of move on with our broadcast, you can kind of see the outline here. We had Mike with the Q&A, so that was really awesome. We'll do a few announcements here in a minute. I'll do a brief update on what's going on at Kilauea in Iceland. Then I'll do a few slides and some images and some information, just kind of reviewing the year that we had with our great channel here. And then if there's time and interest, if there's any specific questions for me, we can kind of circle back and do a little bit with that. So let's go ahead then and make a few announcements. So first of all, first announcement I want to make is I just want to express my gratitude and thanks to the one person that keeps me sane and keeps this thing moving along and organized, and that is Amanda Joe. She's so amazing and so integral to everything we do here. So if you're on the live chat, which I can't even see, maybe give a little round of applause or a little kudos to Amanda Joe. Just, you know, I think I talked to you enough, and I think I thank you enough probably, but just want to publicly thank you for all the great help you've been for the last couple of years. You've been an amazing just kind of partner in this crazy YouTube world that I've kind of jumped into, and thank you so much. Also want to thank Susan Helmer, who's our moderator. She always comes in and helps with these live streams no matter what. So Susan, thank you so much for all you do to help us with these live stream broadcasts. And then finally, the viewers, all of you, our community, our geo-learners, every single one of you, you make this place a better place. You keep me motivated. You ask great questions. You give me ideas. You inspire me. Your zest for learning is just awesome. So just want to thank everyone. You know, kind of the end of the year, it's a good time of year to kind of be thinking about the people that just help you along the way. So I just wanted to thank everyone for that. And then a couple announcements here. We have a few announcements, if you'll indulge me here, some things with field trips and some other things here. But I want to show everyone the channel real quick. We have a few new features on the channel. So there we are, Shawn Willsey, Geology Explained. And if you notice here, there's a couple new things that show up as these little tabs here. So you got videos, lives, courses, etc. But now there's another way if you want to. This is just an option, but another way if you want to support the channel. We do now have memberships available for people. We decided not to create any sort of barrier to additional content because this is an educational channel. So there's nothing hiding behind any sort of paywall or exclusion or anything. So if you sign up for a membership, then you get some of the emojis that show up in the live chat, some little perks that way. And also occasionally I might put out a little poll that's available to some of the members that lets them know, what I might be going for in terms of like maybe doing a certain video or something like that, and you might be able to give a little bit of direction on that. So you can go in and sign up to be a member if you want to through YouTube, but you don't have to. Want to thank a couple people have already jumped on, even though we didn't even announce it. So our first couple members are LK, I hope I'm getting this right, LK McWhorter 6731, Rambler CDT, And then Amanda Joe says our third one is Pam Billman. So those are just a couple people that signed up for memberships. Just want to thank you for your support of the channel. If you're looking for other ways to support the channel, just up here, there's a couple ways. You can do PayPal link. Some people donate monthly. There's this buy me a coffee link where you can just make a donation that way. You can go to our website and there are links to just donate with a credit card or whatever as well. But I do appreciate all the support. That helps me keep Amanda Joe going and just allows me to get out and do more videos. So if you like the content you see here and you're able to support us, great. If not, that's okay too. So we do also have on the website, which Amanda Joe has put together, our merchandise store. So you can go in here and we've got all the merchandise here. You can now also access that through, if you're on YouTube, there's another tab here for store. And what that brings up is just a few featured items, just a few of the things we have at the merchandise store. And then when you click on any one of those items, it'll take you right into the store and you can see all the different colors and such. So again, Amanda Joe, this is all her great work. So thank you for putting all that together. So just a couple announcements there for the good of the order. Let me now share with you some information about some looking ahead into 2026, some field trip information. So a few weeks ago, I announced these field trips in February down in southwestern Utah, St. George area, kind of near Zion National Park. So there's 3 different day trips on each one of these days. The Saturday and Sunday trips have filled. We do have a few spaces left on the Friday the 13th, and that's the trip to Snow Canyon. I'll run these trips again, so if you're weren't able to register for these or they filled too soon for you, don't dismay. We will run these again, maybe even next fall. I could probably do those in the fall and the spring, kind of when the weather's nice down there. So look for those trips. Another set of trips I have, and these are all on the website again, is 2 different day trips around Page, Arizona, kind of near Kanab, Utah. So this is right on the Utah-Arizona border. If you go to the website, you can see the information about that. Great area to explore. There's lots to do around there. So even if you look at that and you say, well, it's only 2 days worth of field trips, that's not worth my while. There's plenty of things to do there. I can give you all sorts of diversions. It's right at the Grand Staircase Escalante National Monument. Just beautiful area there, right near the Colorado River. So those field trips in March. We also have some field trips in May here in the southern Idaho area. So May 1st, 2nd, and 3rd, 3 different one-day trips that you can choose from, going to places like Craters of the Moon, City of Rocks, places around Twin Falls where there's just really excellent and exceptional geology. Looking ahead into the summer, I'll probably repeat some of the trips I did last summer in central Idaho, like around the Sawtooth Mountains, Redfish Canyon, some of those things, but I don't have the dates on those just yet. So just look for those in the next few months as we get into 2026. I'll get some dates on the calendar for some central Idaho field trips. That midsummer time is just a perfect time to be up in the mountains and in that part of the state. And then a trip I ran this last fall that I'll run again this coming fall is this Chasing the Yellowstone Hotspot field trip. I've got dates for that, but we don't have a link up yet. So there's you can't register for this one just yet. We will get that information out in the next maybe month or so. So if you're like me, I like to calendar things way ahead and kind of have things kind of planned out. So I did at least pick some dates for that. There are possibilities some other trips could show up as well, but those are that's probably the lion's share of dates and trips for 2026. One last thing on the website, on the channel real quick, and then I'll finish with a few last announcements for you. We did launch a new, I guess we're calling it a course, because that's kind of what it is. So if you actually go to courses, that's the easiest way to get to it. Oh, I guess it doesn't show up yet, but let me go back here to videos. And yeah, a few weeks ago, we launched our first installment of this series, so Weather 101. This is mainly sort of taught and run by Ben Papandrea, who works for the Weather Company, which is the sort of parent company that owns the Weather Channel and all sorts of other weather companies. So he was very generous in saying, hey, I'd love to kind of teach a basic meteorology class. And I'm really interested in the weather. It's something I call myself somewhat of a amateur meteorologist. And so I'm going to, it's kind of a course for me in taking it myself, but we're hoping to add some more episodes to these. Ben's a really busy guy, but he's committed to doing this. So just encourage you to kind of watch for this series. And the idea is we can start with the basics, and then eventually we'll get into things like severe weather, tornadoes, hurricanes, winter storms. Why does the wind blow? Just some of these fundamental things that a lot of people don't really understand about how weather works. We're going to dive into some of those topics. So that's something there you can look forward to. And let's see. So let's go ahead and do, let's see, what else do I have here? Oh, a couple more announcements, and we'll get to our Kilauea and Iceland update. So one thing is that I have two things coming for you in the next week or so as we head into the holidays. I have a great interview I just did a few days ago with the state geologist of Utah, Darlene Batadian. She actually went to Iceland with me 2 years ago with some YouTube viewers. She's since then become the director of the Utah Geological Survey and the state geologist. So we had a great conversation about her career. I know a lot of people aren't really watching these interview series that I've kind of put together, but I think they're fantastic. I've really enjoyed getting to know people and hearing their stories and their background. So I guess I'd like to encourage folks to look at this interview series. They are a little bit longer videos, but you can pause and stop and watch them in pieces if you want to. But look for that from her, and then we'll also have another interview I just did yesterday with a couple, Judith Hubbard and Kyle Bradley. They are both earthquake scientists that have an amazing newsletter on Substack called Earthquake Insights, and I've actually read their earthquake sort of summaries for some of these big earthquakes I've covered. They actually provide a lot more in-depth detail, really great graphics and such. So talked to them a little bit yesterday, and so you can look for that interview over the next week or so as well. I'll be headed out with the family here on Friday to go to the San Francisco area. Our kids, we grew up doing a lot of outdoors things with our kids, and I think that some of them are a little bit sick of it all. So this year for Christmas, we said, well, what do you want to do? And they said, well, we want to go to a big city. And so we're going to San Francisco for a week or so. I'll try to do some videos while I'm out there. If people have any suggestions kind of in the immediate San Francisco area, I'll try to get out and make some videos. I've got a few ideas in that area as well. And then our last announcement here, if you were with us last year when we did this same kind of broadcast last year, you might remember that it was kind of interesting because we did a contest during the live stream. I basically came up with some questions about the channel, like how many new subscribers joined the channel this year. And then people on the live chat put in their responses kind of rapid fire. And because we had hundreds of people on the live stream, poor Amanda, Joe, and Susan had to quickly look through all those and find the right winner. And while I thought it was kind of fun and just, I thought it was really kind of fun, but they actually it was quite the struggle for them to kind of manage that and deal with that. And so they made me promise never again. But we do want to do a little bit of a viewer appreciation kind of giveaway. So what we're going to do is something a little bit different. If you go to the website and you go to, let me get to my own website here, not the merchandise one. If you go to the website and you come over here to contact us, there is a big red button on this page. It says enter our giveaway. And so basically the idea here is you can put your name and your email, and we'll take and aggregate all those names and emails. So everyone who submits to this, and what we're going to do is basically a random drawing. I think we're going to do 15 different items in the merch store. So we'll give away 15 different products to 15 different winners. So go ahead and put your name in here and your email and go ahead and enter the drawing. This is going to make it a lot easier for Amanda Joe to kind of like organize versus the on the fly in the live chat, people guessing crazy numbers and that sort of thing. So we're going to do this. And then in January, when I get back from Hawaii, we'll announce a specific date. We'll do another live stream maybe in late January or something like that to kick off the year. And we'll randomly draw names from those that have submitted, and we'll announce those 15 winners of those 15 prizes. So we thought it would just be a fun way to kind of keep everyone together, just kind of connect with the community, but also keep Amanda Joe and Susan's sanity intact, which is always high on my priority list. So those are some things to look forward to. Again, if you missed the instructions there, so go to willseygeology.com, go over here to more, come down to contact us, and then you'll see a big red button, enter our giveaway. And that's what you want to click, and then enter your information there. So pretty straightforward. And again, thank you, Amanda Joe, for setting that up and making that so kind of streamlined and easy. So, okay, let's go ahead and jump to an update on Kilauea and Iceland. Let's start with Kilauea first. That webcam view is not helpful at all. Let's try one of the other ones. Okay, so we apparently have some clouds or fog or something going on there. Maybe if we scroll back a bit, we might get a clearer view, although it's pretty dark if I go too far back. Yeah, so really, shoot, not much to actually see. There's a little bit of a view there. You can see the two vents kind of outgassing. But yeah, looks like it's a bit of a cloudy day there at Kilauea. We do have our most recent update. In fact, I'll go ahead and update that and see if they've got one for Wednesday. Oh, good, it populated. So here's our latest update from the USGS on Kilauea. Again, for today, Wednesday, December 17th. Of course, we're sort of in between the last episode, which was episode 38, and the next one, which will be episode 39. Episode 38, if you missed it, which happened on December 6th, was very dramatic. We talked a little bit about that with Mike Poland, who used to work there at the Hawaii Volcano Observatory. But going through the USGS update here, regular periods of glow at the south vent, no glow seen at the north vent. The area has inflated, so we've actually, just like we've seen over the last year, following one of these eruptive events, we have the area rising a little bit as more magma rises into the system. That's causing the ground to actually inflate, and we have tilt meters that record that tilt. So you can see that we've got 23.3 microradians of tilt since the last episode. Looking at the analysis part, which is where the scientists kind of put it all together. So with the inflationary tilt and the continued little kind of seismic tremor that's going on, they fully expect another episode or eruptive episode to occur, and most likely date window for the onset of episode 39 is between December 22nd and 27th. And so could have a Christmas eruption. Maybe it'll be on the 27th, which is my birthday. That would be kind of exciting. A little bit selfishly, I kind of want this thing to erupt on the sooner end, because then I think it would set the stage for when I'm going to be there with some YouTube viewers in early January. We're more likely to see episode 40 if it happens a little bit sooner. If it waits till the 27th, I don't know if we'd catch another eruptive event, within 10, 12 days of that. So, but we'll get what we get, right? No one has any control over this. What's cool about this whole thing is we're almost near the 1 month anniversary, because this all started last year on December 23rd, 2024. So this has been, we're 38 episodes, and it'll be 39 perhaps by the time we get to that anniversary. 39 eruptive episodes in the crater at Halemaumau at the summit of Kilauea over the past year, and they've all been pretty spectacular on their own accord. Pretty amazing stuff. So looking at some other information related to Kilauea, if you're kind of new to what's been going on there, here's a nice map overview. Here's the highway running just to the north of the volcano. Here's the road within the national park. Volcano House is over here. The Kilauea military camp's over here. You can see the Kilauea caldera, which is also called Kilauea. And then nested within that is a secondary, smaller crater called Halemaumau. And the eruptive vents, the place where all the action's been going on, is over here on the western wall of this pit. All the orange is sort of pyroclastic material that's been kind of thrown out into the air. The pink here is the lava flows that have been filling this crater over the past year or so. And so you can see some of the key features there. So that's just a quick little update on where things are happening there. So there's some nice images that have come out from the USGS in the wake of episode 38. Remember, episode 38 was characterized by this really interesting shift in the south vent, which started blowing tephra to the south or southwest. And so because of that, there's actually a map here that shows where all this tephra kind of landed. So our caption here is, yeah, this just shows lava flow and tephra accumulation. So basically there's the two little vents there, and then this kind of green and kind of maroon, I guess, blob and lobe is where all that kind of material fell downwind from those eruptive vents. So they've got some nice images here. The big plume that came out of episode 38 was really impressive. I think it rose to something like 20,000 feet above sea level. So really impressive plume of ash and gas that went straight up. They've got some nice pictures here. This one's almost kind of artsy of, make that a little bit bigger, kind of like the ohia bush or ohia tree in the foreground here, and the inclined vent from episode 38 kind of arcing across the sky there in the background. Let's see, this one's pretty dramatic as well. This one's really cool looking, because you got like the old Crater Rim Drive road with the lines there, and then here's the south vent and all that material. This is sort of like right when the V3 camera was taking a big hit there. So they got some nice images there. Last image from the V3 camera right before the falling tephra took it out looks something like that. So they got, yeah, a couple different nice images there. This one's actually pretty cool too. Let me show you this one, and then I'll show you a couple video clips. Some of the HVO scientists walking along the old Crater Rim road, and you can see the vent down here from episode 38, and then some of that tephra kind of landing over here near the rim. Very cool, good stuff. And then a couple video clips I have for you, and I want to start with this one here from episode 38. So let's go ahead and check out this little clip. There's no sound with this, but it's pretty awesome nonetheless. So there's that kind of ohia bush look, and then there's the two vents. You can see the lava fountaining. You can see clear delineation between the sulfur gases, that's kind of bluish color, and then more of the tephra, more of the ash and small particles from the eruption. There's the lava lake, or sort of the lava flows on the crater floor. There's that tephra material kind of arcing over and hitting the rim of the crater there where the V3 camera was. So they've just got some different little clips they've spliced together here, but some really nice footage of the eruption here from the USGS. Yeah, episode 38 was really awesome. It was just really satisfying. We've had several that have just been I mean, they've all been pretty spectacular. Some a little bit more dramatic than others, but this one I think was really satisfying just from an aesthetic point of view. Just lots of different things going on. You can see some of the fine tephra there, really frothy material, gas rich, stuff we call reticulite. There's the viewing area for the visitors that are, as the eruption's taking place. Awesome, really cool stuff there. So we've got that one, and then two more I want to show you. Again, going back to the destruction of the V3 camera. If you haven't caught that on my channel or other places, this is kind of what it looked like. These are the last images the V3 camera was able to record. Yeah, I don't think there's no sound there. But this is when the vent changed orientation, as we talked about with Mike, and started throwing clots of lava. You can see it really changing here. Now this stuff's falling much closer to the camera. And it just kept shifting a little bit closer to the camera over the next few seconds, and then ultimately some of this material was falling on the camera, which pretty much took it out permanently. really cool images though. Like this is, you know, I showed this to my students, and even the college students were impressed with how cool this kind of looked. So if you ever wanted to know what like death by falling tephra looked like, this might be one view of that. All the material kind of falling there, getting closer to the camera, sending up a lot of ash, just fine material. So those are just little clots of gas-rich lava falling out of the sky. Hard to guess how big they are, but I mean, some probably as big as, I wouldn't doubt some are maybe like basketball size. And then here is where it gets really close to the camera. You can see some red incandescent colors in there as it comes streaking down out of the sky. Closer and closer and closer. And then the camera just goes offline when it takes a good hit there. Just gone. Yeah, there it is. So rest in peace, V3. A job well done. Last thing here is, I found this interesting. This is a aerial flight over the crater after episode 38. So here's the helicopter flying. Just turn that off so you don't have to hear the helicopter whirring. And you can see the big crater floor, the two vents over here. And then what you really see nicely is you can see this change in color right here. This is where all that tephra from when that vent changed to more of an inclined vent, all that material fell across this portion of the crater rim, and you can really see that material sitting on the ground here, covering up these older lava flows here. So it really is changing the topography. It's actively changing the landscape, especially around the vent with each successive eruption. There's kind of a straight down view of the north and south vents, and then they're going to kind of swing over here and look to the southwest at just this tephra-rich landscape, all this brown material here. This is all stuff that fell out of the sky. You can see how thick it is along the crater rim there. It's looking like it's maybe in places, 30, 40 feet, 10, 15 meters thick in some places. Just really nice video footage there. So monitoring data for the past, make that a little bit bigger for you. We'll look at the past week, month, and year. So this is the past week. Earthquakes, pretty much at background levels. Not a lot of earthquakes happening because that magma has a clear conduit up to the surface. We've got these deeper blue quakes over here. That's pretty much where the hot spot starts to come up under the island, and then it shifts over to where we see the eruptive activity taking place. So these earthquakes are pretty common at that depth. Here's the cross section here. Here's the total earthquake counts per day, shown in blue with the bar graph. You can see anywhere from maybe 25 to 50 or so earthquakes per day. That's considered pretty low seismicity for Hawaii. Sometimes we see this much higher, like hundreds of earthquakes per day. The deformation data is the most helpful thing, I suppose, right now, and this is the tilt since episode 38. So you can see with the blue line here, just kind of steady inflation of the summit region. A little bit of a dip down here, possibly due to just a little change in magma influx or something like that. Not sure, but you can see the general trend here of inflation. If we switch over to the past month, now we're looking at a whole month's worth of data. You can see the earthquakes here. There was one larger, I think that was a 4.5 or 6, if I remember right, on the south flank, but that's unrelated to what's going on at the summit with the volcano. You can see all those earthquakes plotted up in sort of cross-section view. Total number of quakes per day, again, anywhere from 20 to 50, 55 or so. That's pretty much the norm. Where those quakes line up per day and with depth, so time versus depth. And then here's the more instructive ground deformation data. So you can see the inflation that went on. Then we had episode 37. Okay, there was a little earthquake in there right as it ended. And then inflation, episode 38. I believe this little blip here was the Alaska earthquake, if I remember right. It happened like a day or so after. And now you can see the inflation that's gone up. So it looks like we need to recover maybe another 10 or so microradians of tilt before the next episode is likely. You can see these last two eruptive episodes pretty much peaked out at about 10 microradians of tilt. And so presumably that would be sort of our estimate. And so they're just more or less extrapolating the slope of this line to where it intersects these peaks here, and that's where they're getting the estimate for when this next episode might take place. We look at the past year, so the whole from December 2024 up to today. Lots of earthquakes, but again, those have been spread out over a whole year, so not quite as impressive. Mostly shallow quakes with the deeper Pahala quakes here. Earthquake counts per day. Well, this is per, let's see, this is per, maybe per week. Yeah, something like that. So it's a greater number, but you can see that earthquakes were higher when the whole thing kind of got started, and they've kind of trailed down a little bit here over time. And then deformation data here, kind of plotting it up a little bit differently here. This doesn't quite show what I wanted it to. You'd have to kind of, they've just got dots here instead of the line, but you can see the trends here, all the eruptive episodes where it drops down, inflation, eruption, drops down, deflation, so on and so forth. So you can see all those trends there, and then kind of this last line here as we kind of build towards the next eruptive event. So that's all I had for you for Kilauea. We'll continue to watch this. I'll try my best to report episode 39 if and when it happens, even if I'm in California. Probably won't get on it like right when it starts. I think with these Hawaii eruptions, what I prefer to do is, you know, kind of jump in when the eruptions may be winding down, because then I can go back to the USGS webcams and sort of pick and choose and pick clips out to kind of show you and more or less summarize the event. Let's do a quick Iceland update. It is dark in Iceland, so that view is not so helpful. But even if we go back here several hours, looks like it was pretty rainy today, but looking out over the Sunnakur craters, you can see the still outgassing and cooling lava fields here. A little bit of snow up there in the highlands. We didn't have a update since the 6 days ago. I did my update 6 days ago when the Met Office did an update. I think the most cool, important thing about Iceland, and I thank the viewer who shared this with me, and I apologize if I don't remember your name, but for those of you who use Google Earth, the big news related to Iceland, and I'm trying to get my Google Earth to open, is that the Google Earth aerial imagery that we've been using, which was from before all these eruptive events took place, has now been updated. So now if you go into Google Earth Pro and you head over here to the beautiful country of Iceland and the Reykjanes Peninsula, and you zoom into the area around Grindavik. Yeah, let's see, let's take off the, yeah, like that. So this is what it looked like before, right? We've got the Fagradalsfjall lava flows over here, but you don't see anything here unless you come down here and actually get it to, so this is August of 2025, so they've actually updated. So now we can see the lava flows. You can nicely pick out the berms that were constructed around the town. You can come up here and see some of these craters that have formed, but this is the current state of affairs with our lava field. You can see the Blue Lagoon here in Svartsengi and the lava flows that came around there, the berms that have been established to protect this area. Here's Silingarfelt, and then you can see these flows kind of going out here, one of our fun little islands that we saw. But anyway, the whole point here is that this new imagery on Google Earth nicely shows the extent of the lava field from all of these eruptions that started in December of 2023. So that is great. Great news that we have a nice new up-to-date, at least as of August 30th, 2025 image for this area around Grindavik. So again, if you use Google Earth Pro, I don't know if the regular Google Earth has it or not. If you don't see it right away, like notice I can like zoom in here and it doesn't show it. The way to get that is to come down here to the little date, click on it, and then you can actually, it's actually been quite useful. You can actually pick any date where they had imagery. Here's like 2015 and see what things look like. But basically pull it all the way over to the right and you should get that latest imagery there. So you can actually, you know, if you want to trace out that lava field or whatever you want to do there. But that shows up now, which is pretty cool. Okay, so a couple things on the update. So the Met Office update, nothing new there. Looking at earthquakes, it's very quiet on the Reykjanes Peninsula last 24 hours. When we look at the last week, it's been actually quite quiet as well. In fact, I don't know if I've ever seen the Reykjanes as a whole with this few earthquakes over a 1 week period. A couple kind of magnitude 3s or so, I would guess. That's 2.5 over here near the tip of the peninsula. A couple here near Lake Klevervat and the Krishevik system, 2.5 as well. And then looking closer to Grindavik, just not. It looks like there's four whole earthquakes, the biggest being this 1.1 near the town here, but just not a lot of seismic activity going on lately on the Reykjanes Peninsula. But we would expect that to increase likely when we get to the next eruptive event, if that's kind of what is in the cards moving forward. GPS data in the area. I haven't looked at this in a while, but I'm assuming it's going to show similar trends to what we've seen. So if we go to the Svartsengi station and look at uplift over the past year, you can see the eruption on April 1st, the eruption this past year on July 16th, and then since then we've just shown the steady inflation. But you can see at the top part here, it does look like it's kind of rounding out, like we're not seeing nearly as much uplift of the station as we did a few months ago, and that's probably indicative of, you know, it's filled or nearly full of magma, gas pressure, and the rocks can only give so much. So we're, you know, it might continue to do this for another month or two. It might be another day or two. We really just don't know. But that would be some of the data to continue to watch, as well as that GPS data. So we have that there. We have the interferogram, and I might have shown this on my last update, but that still shows that the uplift is going on as well. This is from the Cosmos SkyMed satellite, so you can see about 1.5 centimeters of uplift from this purple color to that one there. We have one fringe of color, so that's one full wavelength, about 1.5 centimeters of uplift there. So the uplift continues, and we can see that through several pieces of data. And then the last thing I have for you here on the Iceland update is our good friend and viewer Bruce Garner sent me this morning a new chart, forecast with the modeling he's doing. So he's using 3 different GPS stations shown with the blue, the red, and the yellow up here, and then tracking the elevation of those stations day to day. So you can see where the eruptions occurred. So there's the April 1st event, there's the July 16th event. And basically what he's doing is he's estimating the amount of, or the percentage increase of the elevation from one episode to the next, and then putting that into the model for the next, when the next episode might be, the one we're kind of looking into the future to see, and then basically extrapolating the trend of all these lines here, and then seeing where they match up in terms of dates. And so it looks like we've got anything from the red would be over here. Looks like just into the new year is what he's possibly looking at. So we're looking at as soon as maybe January 4th or so, and as late as the blue one here is maybe out to like January 8th. So maybe the first week or two in January is more or less what he is modeling there. Again, nothing concrete, just a fun way to look at the data and see what might be happening. Selfishly, hope those aren't the dates, because I'll be in Hawaii with folks then. That would be a tough time for me to kind of cover the Iceland thing while I'm taking folks around on a field trip. Okay, so I think we are through the 2 updates. I think the last thing I have for you here, friends, is just kind of my own little year in review kind of summary to share with you. And then if there's a few questions, we'll take a few minutes for those. We went over the field trips. Again, you can go to the website, willseygeology.com. There's a field trip link there, and you can sign up for at least these first 3 those are available right now. We'll get these other ones out soon. But I thought it'd be fun to just look at like numbers, like what we've done with the channel this year. I always think it's fun this time of year to look back and just kind of reflect on things. I think day to day, I'm just like, I'm teaching classes and, you know, just living life like you are. But in terms of what we do here, putting out videos, doing interviews, kind of always thinking of the next thing. And so because I'm always looking ahead, it's fun to kind of look back. And in doing so, it was really cool to me to just see like all the cool things we did. Like, you know, like 2025 was a pretty cool year. We did a lot of cool things. So here's some of the numbers YouTube gave me when I looked these up this morning. So we did 16 live streams, including one that I did on my phone at Kilauea for episode 8 when I was there in February with folks. I tried to just quickly live stream and show you a few minutes of the eruption as it looked on the ground there. So we did 16 live streams this past year. In general, I try to do one a month, but sometimes when we have eruptions, especially in Iceland and such, or something like that, then we'll do one at any time. It looks like there was about 55 or so videos put out, so that's pretty awesome. I think we've got over 650 or so now, so there's a lot of videos on a lot of content there. Number of new subscribers, a little over almost 38,000 new subscribers to our channel, our new community. If you're one of those new subscribers, welcome. I hope you feel like you're included and part of our team here. I hope you enjoy learning with us about the Earth. Total watch times in terms of hours. Here's where the numbers get kind of big and a bit overwhelming. So almost 800,000. So that's a lot of hours. A lot of people watching my ugly face across the screen, hopefully with some cool rocks and some things, but just very flattering to think that, you know, folks would spend some of their precious time here on this earth watching some of our videos. Very cool. Another big number here, total number of views. So this would just be people clicking on a video. Maybe they watched for 4 seconds, maybe they watched for the whole duration, that sort of thing. So pretty cool. Let me just send Amanda Joe a quick message there. Total number of views, so 7.8 million. The video that was the most popular in terms of views this year was the one I did on that Myanmar ground rupture. So 1.1 million people watched some or part of that. In hindsight, looking back on that one, I probably would have done it differently, because if you watched it, I talked for maybe 8 minutes before I actually got to the video, and some people that are very impatient were just wanted me to get to it, and some people didn't want me to talk during it. I don't know. You kind of know when a video is done really well when you start to hear from some of the haters out there. But that's okay. It's part of the business. And then I did 19 interviews. Again, I'm really enjoying these interviews. I know they're not what a lot of you are watching, but I would encourage you to go and just start watching snippets of these. If you want to meet people that are engaged in doing geology or outreach with the public, or they just have amazing stories and interesting careers, I'd encourage you to watch those. Again, I know they're not like watching an eruption or something like that, but I've just found them super, super fascinating. Okay, so that's some numbers, but some other things we did this year. We did some collaborations with some other folks. So there was 2 instances this year where I was with Nick Zentner, and I know a lot of you like his channel and his content. So he and I did a event in central Idaho where we had people show up. Here's the park in Stanley in the middle of central Idaho, small little town, and yet we had, I think that morning there was maybe 50 or so people that showed up and brought their chairs, and Nick and I each kind of talked for the day, and then Nick and I went and did some videos during the day, and then later that evening we were in a different town but did a similar thing, and I think we had about 70 people show up in Chalice for that. So I'm really enjoying meeting other geology YouTube personalities and doing things with them. So I had two events with Nick. This was one. The other one, he showed up on my Grand Canyon River trip, and I had Nick and a lot of other great people on that Grand Canyon River trip for 6 days, and it was just fun to get to know him a little bit better. Also did some things with Rachel Phillips. You know her as Geo Girl. So took her around the Yellowstone area in September. Her and her fiance came out. It was their first time in the Yellowstone area, so I showed her some around. She made some videos, and then caught up with her. And this is Chelsea McRaven Feeney, who does a lot of the great graphics and maps for the roadside geology books. So we went to lunch at the GSA meeting in San Antonio. So it's been fun to meet these people. Super psyched about the new series that we just started with Ben on weather. Hopefully folks will enjoy that just as much as they've enjoyed the Geology 101 course that's out there. So trying new things, right? That's how we grow. That's how we innovate, is just trying new things and seeing how they go. Super psyched again about the interviews I've done this past year, just meeting people I never would have thought I would be able to, get their time, I suppose. Chris, who's in the UK, was really interesting and insightful, just kind of like his path and career in geology. This is Jeff Johnson at Boise State University, who uses a frequency of sound waves, infrasound, to study volcanic eruptions. So he's become a good colleague. This was one of the guides we had on our Grand Canyon trip, Janelle. So just hearing their kind of perspectives. And this is Natalie, who just wrote the Texas Rocks book. So I'm trying to promote people who put out good geology information for the public, and kind of getting to know them a little bit as well. So the interviews, just whether you like them or not, I'm going to keep doing them because I really enjoy them. We also did some field trips this year. So took some folks to Hawaii in February, was able to see episode 8. Fantastic group of people, fantastic trip. I can't say enough of it. If you're one of the people in this photo, hope you're doing well. Thank you for coming on that trip. I'm taking another group there on January 3rd, so just in a few weeks. I'm looking forward to that. Took folks to Iceland in May, as I do every year. Again, another fantastic trip, great group of people, crazy weather, as we often have in Iceland, but also some nice weather as well. So enjoy doing these field trips, just being with people who are super excited to get out and learn. There's nothing better, and the earth is a great teacher. Did some Idaho field trips as well, both here around Twin Falls and then up in central Idaho. This is in the Sawtooth Mountains here. These two photos, these two are closer to Twin Falls. So appreciate everyone who's come out for my field trip. Sometimes people are just driving down the road to get to a field trip. Sometimes people are putting in a lot of effort and coming across the country, or sometimes from another country, to come on these field trips. We did the Grand Canyon trip in July, and we'll continue to do those. We're kind of booked out a year or so ahead, but if you want to get on the waiting list for any of these more exotic field trips, just contact us at the website. There's an email address there, and we can put you on the waiting list so that when it opens up, we can let you know as soon as possible. But Grand Canyon, what can I say? World-class geology, an amazing location. I mean, the best way to see the Grand Canyon and experience it, I'm convinced, is from the river, is from river level. Just fantastic. And then this fall, we had our first Chasing the Yellowstone Hotspot field trip, where we started here in Twin Falls and moved our way up the Snake River Plain towards Yellowstone National Park and looked at volcanic features and processes, volcanoes related to this underlying hotspot that the North American plate has slid over. Again, a great group of people. It was a fantastic trip. They were all really good guinea pigs because I hadn't run a trip like that before, but it worked out, and it is one that I will continue to do again. So that's kind of my last little end of year spiel. You guys all make this possible, and I can't thank you enough for that. So thanks so much. To round up and kind of finish our live stream today, and I apologize, the live chat's still not working for me, but Amanda Jo, at least I can't see it, but Amanda Jo tells me it's working, so I really am kind of flying blind here. Usually I'm able to see, there's usually a button, usually it just pops up and shows me the live chat, but here it's just not showing it, which is really weird. Let me try one more thing to see if this works. Nope. Okay, well, it's worked every other time and it's not working this time. Anyhow, we'll round this out with, I think I've got at least one question here that I can try to answer. And we can go from there. So from low case, specifically in the camera being taken out video, can you explain the sizes of the material hitting the ground and what weight that material would be? Yeah, great question. I don't have a solid answer in terms of the size. I can only sort of guesstimate / estimate the size of the material there. So kind of getting back to, since we do have that up, we can look at specifically what they're talking about here by going to, yeah, like this stuff here, like the size of the material that was falling down around the V3 camera. Yeah, I don't know if that's zoomed in. I don't know if that's just, you know, this stuff falling a few tens of feet or meters ahead of the camera, but I would guess like anywhere from, you know, very fine material. I think the biggest particles maybe are like basketball sized. I mean, they're obviously not circular, but something like that would be my guess. In terms of the weight, these things are probably pretty frothy. It's very gas rich material that's being thrown out of the vent. When it hits the ground, it usually is the brownish material called reticulite. And so some of it may be more dense clots of lava, but some of it may be more frothy material. So this stuff doesn't look as brown as the reticulite. So now that I'm kind of looking at it and talking through it, my guess is that it's, you know, dense enough that if it hit you in the head, it would probably kill you instantly. But I don't know specifically what weight those would be. So really good question there. Obviously, the USGS could go into this area now after the eruption and pick one of these pieces up around the camera site. Maybe they'll put something out on that. That would be cool if they took some pictures of some of these particles that fell by the V3 camera site and showed us, you know, the size to scale, and then maybe weighed those as well. That would be cool information. So if anyone out there is at the HVO and has time to do that, that would be some really cool information. So yeah, I think if there's nothing else, then we might just kind of end this here. Let me just send Amanda Jo a quick message, since she's my only kind of contact to the outside world with the live chat not showing up here. But we've gone here for about an hour, 45 minutes. I think that's pretty good. It was awesome to have Mike Poland on. He's just such a great guest, and it's so fun to learn from him. He's a great communicator, explains things really well. So I think we did the update as well, had lots of fun announcements for you. And if I get approval from Amanda Jo, then maybe we'll, oh, she says there's one question left. Okay. So we're gonna do one more question, team, and then we'll call it a day. So Mark, let's see, Maxim Giesler, 1714. I really wanted to get into volcanology, but in Poland we mostly study sediments. Is there any way for me to gain more knowledge and maybe even certificate in volcanology? Yeah, I mean, I don't, obviously, thank you for your question. I don't know how the system works in Poland, obviously, and certainly some countries have, their geologic setting is going to be such that that's going to be the area you focus on the most. I would say if you want to get into volcanology, look for some opportunities to do some field trips. If there's some conferences in volcanic regions, if you can get some funds together from the university, or maybe write a grant or something that will fund a trip for you to go to maybe Iceland or the Canary Islands or someplace, hopefully not too far, that has volcanology. I do know that some schools offer volcanology field courses. So if you're pretty set on volcanology and you want to go to a specific, you want to go to like a summer field camp type experience where they focus on volcanology, that might be a good thing to look at. I'm not sure about certificate programs. Obviously, as you get your, in the States anyway, you get your bachelor's degree in geology, but your master's degree, you could be more specialized in volcanology and do a volcanic thesis or research project. So that would be some ideas there. And if you need some more clarification, just email me. I'd be happy to help you a little bit more there. So with that, friends, thank you so much for this great live stream broadcast. Thank you so much for making this channel and this community so awesome. You guys are amazing. I have enjoyed meeting so many of you at different venues or field trips. And we've had a great year. 2025 was pretty spectacular. We did a lot of cool things. We learned a lot. We grew. That's the whole point of life, I think. and we will look for 2026 to be just as good. A few things on the docket for 2026. I got a trip to Hawaii with folks in January. February, we've got the field trips down in St. George. March, I'll be in southern Utah for our family spring break, but also do a couple field trips down there. April, I'm excited to go back to where I did my research for my master's degree in Baja California in Mexico. So I'm really excited. There's a GSA sectional meeting in Loreto, which is the town. I studied the rocks just to the west of Loreto, and so I'm excited to go there in mid-April. May will be a trip to Iceland and finishing the semester, and then we're off to the races for the summer. So I'll continue to do what I can to provide you what I think is worthwhile, educational, engaging content, whether that's interviews, updates, field videos, random road cuts. I just kind of make it up as I go. When I have an opportunity to make a video, I put one together, and I will continue to do my best to educate you and myself and learn, and we'll all learn together. So I wish you all a Merry Christmas and Happy Holidays. Hope your family is well. Hope everything is good in your corner of the world. And we'll see you in 2026, team. Have a good one. Take care. Adios.